Hello, my name is Johanna Mark. I'm a senior clinical application specialist with Philips Ultrasound. In this video, you will see a demonstration on how to acquire a 3D or 4D obstetric dataset. After the video, you will be able to acquire and manipulate the volume dataset of a fetal face. These steps can also be used to acquire and manipulate the volume of any other fetal anatomy. Fetal volume imaging is an extremely valuable tool that can provide the ability to make faster, more accurate diagnosis for a variety of obstetrical conditions. Volume acquisition begins with optimal 2D imaging. This step is of utmost importance when acquiring a dataset. The goal is to have a final volume dataset with good resolution and optimal contrast. We can do this by pressing iScan that optimizes 2D gain and TGC, and/or adjust settings such as X-res, 2D opt, dynamic range, depth, and focus. It is important to know what you need to see in 2D to get the desired volume image. To see a volume image of the fetal face, we need to see a profile of the fetal face in 2D and make sure there is an adequate amount of amniotic fluid around the face. Press 3D. On the touchscreen, you can choose between 3D, 4D, or stick. A stick acquisition is used for the fetal heart. 4D is selected by default. If you prefer 3D to be active by default, this can be saved under a new preset. A region of interest box or ROI appears, and on the bottom of the monitor, you will see three options below the trackball diagram: 3D ROI position, 3D ROI curve adjust, and 3D ROI size. By pressing the buttons on the left and right of the trackball, you can go through these options and change the position, curve the volume view line, and change the size of your ROI box. Press Reset Curve to return the volume view line to a straight line if needed. Make sure to include all anatomy needed inside the box. Further settings can be changed to increase the resolution of the 3D dataset. Adjust the angle if a bigger or smaller sweep is needed. For example, an acquisition of the fetal spine will require a smaller sweep and therefore angle than the fetal face. The 2D opt can be changed to res. A gen and pen setting is also available. On the second page of the touchscreen, changes can be made to the chroma map and/or gray map. Press Start 3D on the touchscreen or the middle button above the trackball to start the acquisition. Press Standby on the touchscreen or the middle button above the trackball if you want to reacquire the dataset. On the monitor, you see the sagittal, transverse, and coronal plane of the fetal face, as well as the volume image numbered from 1 to 4. To manipulate the dataset at a later time, press Save 3D on the touchscreen. Another option is to save the 3 MPR plane sweeps as cine loops. On the second page of the touchscreen, press MPR Save and then Save MPRs. The active plane is surrounded by a yellow box, and on each MPR plane we have a region of interest box indicated by the red, green, and blue boxes. The dotted line indicates where the volume image comes from, the direction of the volume view. On the bottom of the monitor around the trackball diagram, you will see the options available for the left and right buttons next to the trackball. Use these buttons and the trackball to change the position, the size of the ROI box, or the curve line. For example, if you want to change the ROI size on the transverse plane, select the transverse plane, number 2, on the touchscreen. Use the buttons next to the trackball. Select 3D ROI size and move the trackball up and down or left and right to change the box size. Let's take a look at how we can manipulate the MPR planes. If needed, we can hide the volume image by pressing Hide Volume on the touchscreen. To find an area of interest, you can slice through a specific plane by selecting the plane on the touchscreen and turning the Slice rotary knob, or turn the X, Y, and Z knobs to rotate a specific plane. At any time, you can press Reset Orientation to return to the original orientation. To see the area of interest in all 3 MPR planes, move the reference cursor with the trackball to the area of interest. Here we now can see the eye in all 3 planes. MPR Touch can also be used to manipulate the reference cursor on the touchscreen. In MPR Touch, you can also slice through the MPR plane and use the X, Y, and Z rotary knobs. If we did not hide the volume, use the pointer to activate the yellow reference cursor and move it to the area of interest. Press pointer again to go back to the 3D ROI options. Manipulating the volume image. If there are structures obscuring the fetal face, a reveal can be used to automatically remove these structures to get a better view of the fetal face. Optimize the region of interest boxes to see the desired volume image by using the trackball and the buttons next to it to change the region of interest position, size, or curve adjust. Or activate MPR Touch to make these adjustments on the touchscreen. Select the one-up layout on the touchscreen to view the volume image only. If needed, press Rotate to rotate the volume image, or Quick Flip. Rotate the X, Y, and Z knobs to align, or the Slice knob to slice through the volume image. Here you can also press Touch View to manipulate the volume image on the touchscreen. You can rotate and/or zoom the image. Different rendering options are available for the volume image. Press Vision on the touchscreen to see different options. The True View Vision or rendering have a light source that can be moved using the trackball around the volume image and in depth through the volume by turning this rotary knob. On the second page of the touchscreen, press Light Positions. You can choose from different positions for the light source. The volume image should be the active plane to adjust the light source with the trackball. Touch View can also be used to manipulate the volume image and the light source on the touchscreen. Tap once on the touchscreen and then move the light around. Turn the rotary knob to change the light depth. Threshold, transparency, and smoothing can be used to optimize the volume image. Select these on the touchscreen or press on the rotary knob to select and turn the knob to adjust. On the second page of the touchscreen, volume chroma, lighting, and bright is available if further optimization is needed. Let's go back to a 4-up layout. The dotted line or volume view can be changed depending from which direction you want to view the dataset. On the second page of the touchscreen, press Volume View. Notice how the dotted line changes position in the ROI boxes. Unneeded information can be erased from the volume image if needed. Select 1-up under Layout to display the volume image. On the touchscreen, press Sculpt. At the bottom of the monitor, you have the option between 3D Sculpt and 3D Erase. With 3D Sculpt, you see a green cross on the volume image. Using the trackball, move the cross to where you want to start removing information and press the middle button above the trackball. Draw the line around the information you want to delete and press the middle trackball button again. Select 3D Erase with the button next to the trackball. A gray dot appears on the volume image. Move the dot to where you want to remove information and press the middle button above the trackball. Slowly move the trackball to remove the information from the volume image. When you removed incorrect information, press Undo on the touchscreen to get the information back. When done, press Close. When using Touch View, Sculpt is available as well. To do a 4D examination of the fetal face, we will go back to 2D. Press 3D and select 4D on the touchscreen. Adjust and optimize your region of interest box. Keep the transducer still and press Start 3D or the middle button above the trackball. The live volume image appears on the left side. To adjust the position of the light source with the trackball, select the volume image number 4 on the touchscreen or select a 1-up to display the 4D image only. Press Freeze. On the second page of the touchscreen, select CinePlay and select the Cine Speed on the first page. Press Acquire to save a Cine loop of the 4D. When in 4D, you can directly acquire the dataset by pressing Save 4D on the touchscreen. For 3D and 4D acquisitions, different settings are needed depending on the fetal anatomy that you are looking at. After you have optimized your dataset and volume image, you can now save your settings, which include multiple 3D and 4D parameters, by pressing Save 3D Preset on the touchscreen. Provide a name for your preset, and you can directly use this in the future with all your settings saved, for example, an acquisition of the fetal face, fetal spine, or fetal brain. Additional functions include Alt Print, which can be programmed to a printer. GI 3DQ is a QLab application to manipulate the dataset. QLab is also available off-card. iSlice is the possibility to get a tomographic view of the volume. Thank you for watching. On how to use our FlexView option, please refer to the FlexView video.